Hello, so today we are going to do this problem which is part of Leetcode October Daily Challenge, largest perimeter of a triangle. So the problem basically is that we have an array of numbers and we want to return the largest perimeter of a triangle with a non-zero area that is formed with 3 of the lengths in the array. And if it's impossible to find a triangle with a non-zero area, we want to return 0. Right? So for example here, well, just 3, so we return them. Here it's not possible to form an area without with value non-zero, because there is a rule, just a mathematical rules with a triangle where you need the bigger side to be smaller than the sum of the other two sides, right? If you just play maybe with drawing triangles or play maybe with sticks, you will get an intuition for that. But it's just a known triangle rule, which is that the larger side needs to be smaller than the sum of the two other ones, and that's not valid here because 2 is not smaller than 1 plus 1. It's equal, right? So this is not valid, right? But you may say, okay, what about this one? Well, this one, if we use 2 to 1, well, 2 is smaller than 2 plus 1, right? It's smaller than 3, so this one is valid, so we can return that perimeter. So that's the idea. So what this tells us, it should be pretty simple. We just need, since we want the largest perimeter here, we need to maximize the values of the sides. So we just need to traverse the array from largest to smallest and make sure whenever we find any 3 numbers that have the property that one side is smaller than the sum of the two other sides, we can just return that, right? So pretty simple solution here. So first we of course need to sort it. We need to sort the array, and then we want to go backwards so that we can go from largest to smallest. We could also sort the array in reverse order if you want. So here we want to go from largest, so we need 3 numbers each time, because that's what the perimeter of a triangle is. So we need 3 numbers and we go backwards, right? And the property that we said is one side, okay, larger side, of course, needs to be smaller than some of the other two, right? Okay, so let's take our large side, which is at position I, plus 2, right? So the one towards the end. We need this to be smaller than I plus 1 plus at I. So basically this tells us that this is a valid rectangle, so the area is not 0. Sorry, valid triangle, which will be area different than 0, right? And if this is the case, well, we can just return the perimeter, which is the sum, right? So the sum of the 3 numbers. And so to return that, well, we can just start from I and go to I plus 3. This will give us the sum of I plus 1 and I plus 2. And then if we traverse it and we didn't find such a valid triangle, we need to return 0. So pretty straightforward there. Let's submit. Okay, so that passes test cases. Now, in terms of time complexity, we are doing here O of n log n, and then O of n here. And this is O of 3 because at most we do the sum of 3. So overall it's O of n log n. That's the higher term. And in terms of space, no extra space, so of 1 space. Yeah, so that's pretty much it for today's problem. Thanks for watching and see you on the next one. Bye.